talk about the column oriented storage. Have you ever wondered how the tools like Snowflake or Google BigQuery can process billions of rows of data in the blink of eye, while Excel struggles with a few thousands of rows? Well, the secret lies in how data is stored, and this is where column oriented storage comes into the picture. Okay, so let's start with the basics. Column oriented storage is a way of organizing the data in the database where all the values of the columns are stored together. Now, to understand this better, let's talk about its sibling, that is a row oriented storage. So let's take an example here as a order ID. Let's take as customer name, his or her age, product ID and price. Okay, so order ID would be 1, 2, customer name, let's take as Archie or me. Age as 24, 25. Product ID will be 1, 2, 3 or 1 to 5. Price, let's take 500 and here 1000. Now, in the row oriented system, the data will be stored like 1. Here it will be RG 24, 1, 2, 3 and 500. And the second will be 2, me 25, 125 and 1000. It is row by row. All the values of a single row are stored together. This makes sense where you frequently work with the whole row, such as bank transactions or user registration. But now let's talk about the column oriented storage. So here let's take the same example, and it is okay. So how the column oriented storage will be look like as order ID, and here it will be 1, 2, customer name, it will be Archie Omi, age will be 24, 25, product ID is 1, 2, 3, 1, 2, 5, and price is 500 and 1000. So instead of storing all rows together, all the values in single column are grouped and stored together, as you can see. Okay, so why this matters? The way the data is stored completely changes the behavior of whole database. In a row oriented system, it is fast to retrieve the entire row having the ID 1. But in a column oriented storage, it is fast to perform operation on single column. If you want to find the sum, average or the highest price, you can directly query on these columns without touching the other data. So this was the one use case of why column oriented storage is awesome, because it is to retrieve the data faster. But the another use case is it is amazing for compressing the data. Columns often have similar or repeating values. For example, if it is a gender column, then there would be 2 or 3 genders only, right? M, F. So here the values can be compressed using the techniques like run-length encoding or dictionary encoding. This compression not only saves storage space but also speeds up query performance. We will talk about this both after some time. Let's talk about advantages of column oriented storage. Okay, so let's talk about the RLE, that is run length encoding. This technique is simple and effective compression technique used to reduce the size of repetitive data by encoding consecutive repeated values of a single value followed by the count of repetitions. So let's see how it works. Instead of storing each repeated value separately, you store the value once with the number of times it is repeated. For example, suppose we have the following data in the column, that is A, B, B, C, C, D, 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 D. So using the run length algorithm, it will be stored as A. Here the A is 3 times. Then B is 2 times, C is 2 times and D is 4 times. So here it is compressed into this. So RLE works exponentially well when the data have lots of repeated consecutive values. Just like this example. It is very easy to implement and computationally very lightweight. But it also has some of the limitations. Like we can't use it when there are very less repetitive data because it won't save much space. Okay, so now let's talk about the dictionary encoding. Dictionary encoding compresses the data by replacing frequently occurring values with shorter numeric or symbolic codes. It creates the dictionary to map each unique value in the dataset to a compact code. So, how it works? It builds a dictionary of the unique values in the column and then replace each value in the column with its corresponding code from the dictionary. Okay, so let's take an example and understand in better way. Suppose this is apple, this is banana. This is the example and it will be stored like a map structure. So it would be like if it is apple, we are storing it as 1. If it is banana, we will store as 2. If it is orange, then we will make it as 3. So here it will look like as 1, 2, 3, 1, 2, 3, 1, 1. So here the encoded data will use the numbers instead of the full string. So this dictionary encoding will work well with a limited number of unique values. And as numeric codes are faster to process than strings, it improves the query performance. Most of the time it is used in the combination with the RLE, which we have just discussed. In column oriented databases, RLE and this dictionary encoding are often used together for better compression. So let's understand it by taking an example. Here it is apple. So here the data is not as simple as it looks because we are just taking it to understand the concept. Usually the data, let's take an example, it is an Amazon. So they are having the order ID, customer ID, seller ID, product ID, dates, address, lots of data. So it is very complex. And here we are just understanding how it will be encoded. So just take that in a mind. Here it will be grapes. Let's take it as a, yeah, sorry. Okay. Now let's give it the unique value. Apple will have 1, grapes will have 2, and pea will have 3. So now this is encoded into numeric value, and now we will use the RLE. So it will have 1, 1, 2, 2, 3, 3, 3. So here one will have one. There are two ones, there are two twos, and there are three threes. Okay, yeah. So this combination maximizes the compression ratio by first replacing the values with compact codes and then reducing the repetition. Okay, so this was all about encoding. Let's talk about the advantages of column oriented storage. As we have discussed, it is very useful for faster analytics. That is, if you want to find the sum, average, or count, it is best because it scans only the relevant column. Second, for better compression, as we have just saw the encoding techniques, you know that it is better for compression. It also reduce disk input output operation. Since only the required columns are read, there is less data to scan, which means lower input and output operations. It is perfect for OLAP. If you don't know about OLAP, it is online analytical processing. Just if you haven't watched the previous videos, then just must go to that video. It will be very helpful to understand the concepts better. So column oriented storage is helpful for OLAP systems where the focus is on analytics and reporting. Okay, so let's talk about some of the drawbacks. So here are three drawbacks. First is slow write performance. Writing data is slow because it has to split the data into multiple columns and store them separately. Second is it is not ideal for transactions. Column oriented systems are not ideal for the applications that frequently update the individual record like bank accounts or inventory systems. Also, joining the data from multiple columns can be less efficient compared to the row oriented databases. Okay, so let's talk about where the column oriented storage are used. First, it is used in data warehouse. Tools like Snowflake, Amazon Redshift rely on columnar storage for blazing fast analytics. Second, it is used in time series database. It is used in the databases like Apache Cassandra or ClickHouse, especially for storing the logs or monitoring metrics. Third, big data analytics. Columnar storage is a backbone of big data platforms like Hadoop and Spark. Okay. And please make sure you like this video, subscribe to my channel, and leave the comments if you have any kind of doubts or suggestions, or you want any particular topic so that I can make the video on that. Check out the descriptions if you want the more resources supporting the information which I have explained, and see you in the next video.